In 286 walls and gates, it's a median LEETCODE question. So you're basically giving our m multiplex n grid rooms initialized with these three possible values. So -1 is a wall or an obstacle, like something like this, or a wall, and 0 is a gate, like this, and infinity means an empty room. So all these here, like the white space, is empty room. We use value, so they also give you this value to represent infinity, as you may assume that the distance to a gate is less than the infinity value. So basically, the final value should be less than the infinity. Fill each empty room with the distance to its nearest gate. If it's possible to reach a gate, it should be filled with infinity if it's impossible. So looking at this example here, and we can see these rooms all represented by the infinity. -1 is the wall and 0 is the gate, right? So it basically want you to fill the room with the distance to the nearest gate. So like for example, this one, the first cell, right? We can go 1, 2, 3 to this gate here, or we can also 1, 2, 3, 4, like a 4 reach here. If that is the case, then this number pick the shortest distance should definitely be 3, right? Because this distance is shorter. So if you go by each cell, then you kind of have to calculate the distance to each gate and take the minimum number between the 3 or 4, whichever one is smaller, and update it here. The numbers that do not return anything, modify rooms in place instead. And if it's -1, then -1. There are some constraints here. And then the company asked these questions, or Facebook asked the most 17 times in the last 6 months. So when I look at this problem, I prefer to if you think about the shortest distance, we always use buffer search, and a buffer search we always use a queue to pop the value, right? That's like a formula that you can use. But if you think of this problem differently, like instead of going from each empty cell to the gate, you can actually take all the gates, add them to the queue, and then what you want to do is do the buffer search on each gate to find the value, the shortest distance. And whatever you visited, you want to put in the visit so you don't visit them again. But then if you go through from the gate, it's guaranteed that you're going to find the smallest value in it, when you use BFS. And you can see if I go from this gate here to here is distance 1, and I'm popping the first value. And after I'm popping this, and I'm gonna pop this one value off the queue, right? And I'm gonna pop layer 2 and this, and then this, right? And then after I pop off this, I'm gonna pop this another layer, basically length of queue, and then each time I pop, the distance is gonna need to add a 1, right? So the thought process is that we're gonna use BFS and go from the gate. We're gonna add the gate to the queue first, and then we're gonna calculate the distance, popping each level by level from the gate. And then if these are the empty cell, I'm gonna update it with the distance, and I'm gonna add them, every single one of them, append to the queue, and also add to the visit set. So make sure that I don't visit them again, and it's guaranteed to get the shortest distance. So let me show you how to do this in the code. So I'm gonna have a visit set first to make sure that to add the cell to the visit if I have visited all of them already. And now what I'm gonna do, I'm gonna define the room, basically the graph, and the its length of rooms, and calls equals to length of rooms 0 in this case, right? So then I'm gonna define a queue. I'm gonna use dq to pop off the value. So next what I'm gonna do is I'm gonna add all the gates to the append to the queue. So gate is 0. Okay, this is what I'm gonna do. So for R in range rows, for C in range calls, so basically I'm gonna iterate through every single cell. If rooms are C equals to 0, basically that means it's a gate, right? What I'm gonna do is append this gate RC to the queue. So now if I look at the queue, I should have the RC for this gate and then this gate, right? And then I'm gonna assign it as a distance to 0 at the beginning while I go through the queue, while queue exists, right? I'm gonna say for I in range length of queue. This is how I iterate through the range. And then I'm gonna start popping from the queue, and the queue dot pop left. When I pop, I got the let's say I pop from here, and then I'm gonna get the RC for this gate, right? So the next step is that I'm gonna calculate the RC's neighbor. So for the RDC in basically all 4 directions, and I'm gonna say 0, -1, and then 0 and 1, all 4 direction. 1, 0, and I'm gonna say -1 and 0, right? For the directions, I'm gonna calculate the new row column count. Basically, it should be R plus DR. So basically, DRDC is this is 0, 0, those value, right? And then I'm gonna calculate the new cell number, basically their neighbors cell row count R, and then C plus DC. And then I know that it's the gate's neighbor. So once I calculate the gate's neighbor, right, I will see this, and also this one. But I want to do a condition check to make sure that first that they are inbound, right? Because I'm not gonna do the cell like up here, that I'm just simply not gonna check it. And also 0 minus call and calls, and also rooms row, the new room column. I want to make sure that it equals to, let's see, the infinity means an empty room. I want to make sure it's a room because we only wanted to calculate the room's value, right? So then I'm gonna calculate this. So basically, if it equals this room and the row call I have not visited before, not in visit, then what I'm gonna do is I'm gonna assign the rooms. I'm gonna assign the rooms a row call. It's gonna be equal to the distance. So once equals to the distance, right? Oh, so what I'm gonna do is I'm gonna have to add the distance, because each time when you iterate through the queue, you're gonna have to add one more distance. Add a 1 to the distance, because if I don't have this line, then here the distance gonna be straight equal to 0, which is not right. I gotta have to add the row every single time. And I think that's it because it said do not return anything, modify this in place instead. And we already modified this in place. So then I'm gonna do is I'm gonna append the row column to the queue so that I can iterate through this to pop the next layer. And then I also want to make sure that add the row column to the visit set to not visit this same cell one more time. And let's see. Oh yeah, I typed it wrong. It's rooms. Yeah. Okay, it's accepted. Let me know if it's helpful or if you have any additional questions. If you like my video, please subscribe to my channel and I'll have more video upcoming for you soon. And I'll see you. Bye bye.